Hello everyone. So in this video we'll be doing determinants of order 3. So you must have studied in school about how to find determinant by cofactors. We'll use the method expansion by cofactors. So suppose A is a 3 cross 3 matrix, then you can find the determinant of A as the first element. So we'll eliminate this column and this row, then determinant of the remaining part. Similarly, so the remaining part is A22, A23, A32, A33. Then similarly, we'll remove this column and this row, then the determinant of these remaining parts. So it goes as -1 to the power I plus j. We'll discuss this in detail in the next classes. So it is the coefficient is plus, then minus, then plus, then subsequently minus, and then the third element, remove this, and then the determinant of this. So this is how we'll get the determinant. Okay, so let's solve an example. The A determinant would be expanding along this row because one of the element is 0, so it would help, or we can expand through this column as well. So it would be 3 times determinant of this thing. So 3 times determinant of 1, 2, 0, 3 minus 0 times something would be 0 only, plus 2 times determinant of this, -1, 5, 1, 2. So this becomes 3 times 3 minus 0 minus 0 plus 2 times -2 minus 5. So we have 3 times 3 plus 2 times -7. So this is 9 plus -14. So this is -5. So determinant of A is coming out to be -5. Now suppose we have a system of equations where there are 3 variables and 3 equations. Now the 3 variables are x1, x2, x3. The coefficient matrix A is A11, A12, A13, A21, A22, A23, A31, A32, A33, and the right hand side is B1, B2, B3. Now we have discussed the Cramer's rule as well, and according to Cramer's rule, the solution would be x1 is replacing the first column with the right hand side, and the rest of the matrix is same. And divided by the determinant of A. Similarly, x2 would be replacing the second column with the right hand side. So 3, 1, it is B1, B2, B3, and then A13, A23, A33 upon A determinant. Similarly, x3 would be A11, A21, A31, A12, A22, A32, and then the third column would be replaced with B1, B2, B3 upon A determinant. So now suppose this the example from the book itself. Solve the following system of equations by using Cramer's rule. So here we have A equals to 2, 4, 0, 2, -1, 0, 2, 6, -3. And we have B equals to -3, 8. This is -3, 8, and -12. So we know x1 would be Okay, so before this, okay, the space is limited. X1 is B1, B2, B3. Then these things would follow. So okay, this is A12, A22, A32, 13, A23, A33. So this would be upon A determinant. So this would be -3, 8, -12, 2, 0, 6, and -1, 2, -3 upon A determinant. So this would be x1. Okay, so finding what A determinant would be. Okay, so it would give us clarity what A determinant would be. Now, we'll just erase this up. So we know this is x1. This is equals to x1. Now, finding A determinant. So suppose we are expanding through this particular column. So it would be 2 times 0 into -3, which is 0, minus 2 into 6, so -12, minus 4 times 2 into -3, minus -1 into 6. So this is -24, minus 4 times -6 plus 6. So this cancels out. So 4 into 0 is 0. So this is -24. We have A determinant equals to -24. Okay, so I'm writing it down here. A determinant equals to -24. Now solving for x1. Okay, so we'll so A determinant is -24. So the numerator would be, so if we expand it along the second row, so it is -8 times, because A21, so 2 plus 1 is 3, which is odd, so minus sign. We'll discuss this in later class. Then 2 into -3 minus -1 into 6 plus 0 into something, which is 0, minus time 2 times -3 into 6 minus of 2 into -12. So this would be -8 into -6 plus 6 minus 2 into -18 plus 24. So this cancels out. So this is 0. So we are left with -2 into 6, which is -12. So the value of x1 would be -12 by -24, which is half. So we know x1 is coming out to be half. Similarly, we can find the values for x2 as well. And I would suggest you to solve these questions, solve these values, because in the exam you might end up making mistakes. So for x2, it would be 240, then b -8, -3, 8 and -12, then -1, 2, -3. So determinant of this upon -24, which was A determinant. So expanding through this column, we have 2 into -24 minus of -24 minus 4 into -3 into -3, 9, minus of -12 into -1. So this becomes plus, so this would cancel out. So this becomes 0. We are left with -4 into 9 minus 12. So which is -4 into -3. So this is 12 upon minus 24. So we have x2 is minus half. Similarly, you can find for x3. The value of x3 would be so the value of x3 would be 240, 206, and then minus 3, 8, minus 12. Determinant upon a determinant. So a determinant is minus 24. The numerator becomes expanding through this column only 2 times 0 minus 48 minus 4 times minus 24 plus 18 upon minus 24. So if you'll solve this, this is minus 96 minus 4 times minus 6. So this is minus 96 plus 24, which is minus 72 upon minus 24. So x3 is coming out to be 3. So you can substitute these values and check for these equation as well. So this is 2 into half plus 2 into minus half minus x3 3. So this 1 minus 1, this becomes 0, minus 3 minus 3. 4 into x1, checking the second equation, into half plus 2 into x3, 2 plus 6, 8. This is also satisfied. So checking the third equation, 6x2, 6 into minus 1 by 2 minus 3 into 3 minus 3 minus 9, which is minus 12. So all these equations are satisfied. So this is the final solution. Okay, now the geometric interpretation. We have done the geometric interpretation for 2 cross 2 vector. That was important, so you need to know the proof of that. In case of geometric interpretation for a 3 cross 3 vector, it is not so important, and just you need to find is, so in 2 cross 2 we were finding the area of parallelogram. So you'll see in the previous video I have explained it in detail. This can come in exam, but 3 cross 3 you should just know that 3 cross 3 the determinant corresponds to the volume of the box spanned by the 3 vectors. So it is just the volume of the box which is being spanned by the 3 vectors. Okay, now this is a bit important. Sarrus Rule. So this is confined to a matrix which is of order 3. So we cannot generalize this to determinant of order higher than 3. I'll tell you how we are supposed to find it. So A11, A21, A31. This is the original 3 cross 3 matrix that we have. Now in this, what we'll do is we'll add these first 2 columns again. So it would become A11, A21, A31, and then A12, A22, A32. So in total we would have 5 columns and 3 rows. So basically we are not adding this again. Okay, now these coefficients, these diagonals, the first diagonal is added, second diagonal is added. So these coefficients are multiplied and then added. So what we have is A11, A22 into A33 plus A12, A23, A31 plus again A13, A21, A32, and from this we will subtract the these diagonals, first, second and third. So this would be minus a13, a22, a31 minus a32, a23, a11 and then minus a33, a21, a12. So on simplifying this, we'll see this is a11. Okay, so on simplifying this, you will get this thing, a11 into a. We'll get the matrix itself, a22, a33 minus a32, a23 minus a12 times a21, a33 minus a31, a23 plus a13 times a21, a32 minus a22, a31. This is the final result that we'll get. Okay, now suppose the question asks you to find a determinant using Sarrus rule, where a is this. So we know a determinant would be equal to, we have 1, minus 1, 3, 5, 1, 2, minus 1, 3, 1, and now we are supposed to add these first two columns. So it would be 1, minus 1, 3 and 5, 1, 2. Now as we have seen before, we need to add these diagonals sorry, so we need to first multiply these coefficients and then add them. So this into this, so we have 1 into 1 into 1 plus 5 into 3 into 3 plus minus 1 into minus 1 into 2. So the sum total becomes 1 plus 5 into 3, 15, 45 plus 2. So this is 48. From this we need to subtract this and this. So minus of 3 into 1 into minus 1 plus 2 into 3 into 1 plus 1 into minus 1 into 5. So 48 minus of this whole thing. So this is 48 minus of 3 minus 3 plus 6 minus 5. So this becomes minus 8 plus 6, 48 minus of minus 8 plus 6 minus 2. So this becomes 50. So if we'll check, the determinant of A is coming out to be 50. So that's it. And 13.3 is not part of your course, so we won't do this. We'll directly move to 13.4. So I'll be covering this in the next video. Thank you.